Hi all. In the previous tutorial of tree series, we talked about various components of tree along with its traversal strategy. Now as a part of this tutorial, we're going to talk about how we can build a binary search tree by using backend implementation. So let's get started. So I have already created a couple of classes. The first one is node class, which is holding the three data member along with one arc constructor, and the second class is build tree, which we're going to use to provide the implementation of this logic. So let's get started. Firstly, we'll be creating one static method. The return type of the method will be node, and method name will be create new node, which will be expecting uh, two input parameter. The first one is root of node type. The second one is data of int type. Right. So inside this method, we have to handle three use case. The first one is when root is null. So when root won't exist, it means when we are trying to add the first element into the tree. So in that case, the first element we have to make as the root element because there won't be any root exist so far. This is the first use case. The second use case is when uh, data is less than uh, root node value. All right. And the third one is when data is greater than when data is greater than root node value. So we have to handle these three use cases while designing the build tree implementation. So let's get started with the first use case when root is null. All right. So we'll be handling that by checking the using the null check. If the root is null, right? So we'll be creating new node which will become a root node, and we'll be passing data as an input parameter to this constructor, and we'll return that object back to caller, right? This is the first use case. The second use case is when data is less than the root node value. So in that case, we have to check what's the current value of root. So that we will be checking by using the root dot data. If it is less than the data, sorry, we are checking when data is less than root value. It means data should be like this. If this data which is coming as a part of this method input parameter, if that is less than the current root value, in that case uh, we have to create a node to the left side of the tree. So we'll be doing root dot left is equal to create new node. We'll be calling the same function again because we are doing this by using recursion. So root dot left comma data. All right. This is the second use case. Now the third use case is when data is greater than the root node value. So that we will be again using if check root dot data is less than data. Mean data is greater than root node data. So in that case, we're going to create root dot right is equal to create new node and root dot right data, because we have traverse to the right hand side. If if data is if data is greater than the current node, right? Let me explain you here. See, the first time when we are trying to add 50, so 50 root is not present, so we are checking uh, whether root is null or not. If root is null, in that case we are creating a single uh, node with its data, and we are assigning it as, we are creating it as a root node, right? That is what we have done here. Now when it comes to the second element, so we have to check whether the second element is greater than the root node element or not. So in that case, the first check we'll be doing, root dot data is greater than the data. Data is means second time we are sending here 35. 35 is greater than 50 or not. So 35 is greater than 50. So here it is 50, it is 35. It is always less than, right? Data is 35 and this root data is 50. It means it is less than, so we have to go to left hand side. That's why, see, uh, it is coming as left hand side to this root node, right? Same case when it comes to 60, right? The 60 is greater than the root node, so in that case this will be fail, right? It won't be true. So in this case this condition will be true because root data element we have currently 50 and data value we have 60. So this condition is true. We will be routing to the right hand side to the root node, right? That's why we are creating a new node uh, towards the right hand side and then assigning value to it. That is nothing but a 60. So you can see 60 will become a right node of the root node. All right, so likewise we'll be checking these three checks. This will execute only once when there won't be any node exist, there won't be any root node exist. Once that is done, so it won't execute again. All right, so these two conditions will be keep executing until unless your elements from the list won't be empty. So at the end, once the traversion is done, you have no element left in your list, so we'll be returning root node back to the caller method, right? So we are done with the logic implementation of building a binary search tree inside this private method, because we don't want to expose this logic to outside. Rather than, we'll be creating one another public method without any input parameter, which will be exposed to the public, and they just gonna call that method, and that method will be internally calling this create new node method to construct a binary search tree. So let's quickly write that method implementation and exposed it. So we have created a static build method. Inside it we have created a list of elements which we want to add as a part of the tree. So the first root node which we're going to add here is 50. The remaining elements will be a child node of this root node, which is 50. So we are writing a for loop, and inside this for each loop we are calling create new method by passing the root node and the element one by one. And at the end, once the root is the tree is constructed, so we'll be returning root back to whoever will be calling this build method from outside. So that is how we'll be exposing the implementation of building binary search tree to the outside. So now going forward, we'll be working with the implementation of this tree traversal. So where we will be calling this build method, and which will construct the tree for us. And we won't be creating tree for all the traversal implementation. We'll be reusing this class, this logic. That's why we have written it like that only. So in next tutorial, we'll be discussing the traversal of the binary search tree by using this implementation. So stay tuned for other videos. Thank you.